All right, monthly space news. A couple of highlights here. I'm calling it Orion and the 10 dwarfs because it has the main mission, which is Orion, the capsule, and a whole bunch of small secondary payloads. There have been some other lunar launches, and the other big thing was the Soyuz leak problem. And then we'll just go over recent launches to space. So Artemis 1, it succeeded, the main mission in particular. So yeah. Finally, after a lot of money and a lot of time, they finally did. I think that's really a great thing. The capsule splashed down on December 11th. What happened to it after that? Well, they picked it up at the ship and they brought it back. It's now back at Kennedy Space Center, where they're now going in and basically disassembling it. They want to look at every single part because some of this stuff you want to see what kind of damage there was for the heat shields and all that kind of thing. The test dummies, see how they did. They had at least one test dummy involved in that. And then actually, it's like a bunch of vultures. They're going to scavenge the thing. They're going to pull out the avionics, the electronics, the antennas, and various other parts. Those are actually probably, surprisingly, on the critical path for the next launch. It's kind of funny. Instead of buying a lot of them once, they're actually reusing them, which is kind of a good thing. Part of the problem it takes so long is I think they have to actually cut through some welds to get at some of this equipment, the way it's built. A crew seat, there's a crew seat that's being recycled. They're using that. Their plan in general is to use more in the Orion missions, and they're not there yet, so they're doing it kind of piece by piece. Now, the secondary CubeSat payloads, CubeSat, remember, a 4x4x4 cube as a size unit. Most of these payloads were about 6 of those units, so kind of a briefcase kind of a size, maybe 20 to 30 pound kind of range typically. There were 10 of those that went up with them, and they were just basically up there in the fairing just below the Orion capsule. There was a lot of concern because of delays in Artemis 1. All these things were sitting in there for a couple of years. They were charged up. They all had rechargeable batteries to be recharged by solar cells once they're in operation. And they couldn't get at all of them, even to keep them recharged. I guess nobody ever thought it would take that long. They just didn't design for that. And maybe there's a lesson here that they probably should. Some of those rideshares have failed, and maybe that's part of the reason. There were 3 that just never even established contact. So they were just dead from the beginning. We'll never know why they died, but maybe the battery was part of the problem. The ones that died, it's too bad. There are a couple of really interesting ones. The Near-Earth Asteroid Scout. This was the one that had a solar sail. They were going to sail to an asteroid, a small asteroid. We did cover that in one of the earlier news sessions. It was a really pretty innovative kind of a thing. The second one was an actual lunar lander. The thing weighs about 31 pounds. This is from the Japanese government, the Jackson Space Agency. Omotenashi. It again completely failed. They just never made contact, so they don't know what happened. Too bad. It would have eventually dropped down. It had an airbag. Japanese make airbags. They had some problems with airbags actually, but that was actually their final landing strategy, was to have a big airbag, and they used it. That was part of that 31 pounds. There was a kind of an amateur one called the Miles Space Team, testing some kind of plasma thruster. Again, no contact on that. There's a Lockheed project called lunar, I'm not sure how you pronounce it. It's doing some tests with spectroscopy, basically taking measurements around either the moon or the Earth. They got a weak signal back, so it's not quite clear what's going on with that, but I think it's sort of in the failure category, maybe not. Now, there's one called CUSP, which is tracking space weather, meaning solar particles, magnetic fields, effects of the sun, pretty much, and what damage it might do to spacecraft. That was actually okay at first. But then they started having battery problems. They got spikes in temperatures and that kind of thing. They started getting a lot of reboots. They lost contact a couple of times, and finally, it just died. Now, they're still hoping, it may come back. They think in a couple of months it's going to be in a place where if they manage to deploy some of their solar cells, maybe it'll recontact. So there's still some hope for this one. But this one, it may have been because of the battery being so heavily discharged that maybe it got damaged or something. There's another one called the Luna H map. This is a hydrogen map. Basically looking for water. They're looking for ice on, but they're doing it specifically by looking for the hydrogen atoms that they're part of the water molecules. That one was okay. It started off, they still had 70% of their battery power. No problem with that one. Their problem is a propulsion system. All these things typically have their own propulsion. They go up, they're put in place by a giant rocket, but the exact orbits they go into, they do that under their own propulsion. They had trouble with that. It's not working. It's just flat out not working. So there's a valve stuck. What it is it's some kind of ion engine, and there's some valve that involves flow of ions, and it's stuck. They think they can heat it up and maybe get it going again. They've already missed their window to get into where they're supposed to be, which is a polar orbit around the moon. They missed that, but they're still in the general area. They figure if they can get it working, they could actually finally end up in 2024 where they want it to be. So it'll take some time, but it has to be done in the next month or so. So the jury is still out on this one. And some people have suggested maybe that was due to the long delays also, just the metal sitting on metal, not moving for a long period of time. Those atoms start sticking together. So that could have been the problem, but of course, nobody really knows. There are operational payloads. So there are at least 4 that are operating as planned. There's one that was another Japanese space agency probe called the Equalus, scanning for radiation and plasma in the general area of both Earth and the Moon. There's a project called BioSentinel, and this one was actually heading off into deep space for a solar orbit. And they're taking with them some yeast, but they were going to study the effects of radiation in deep space on life, yeast in this case, representing us. There's another one which is also prospecting for water ice called the lunar ice cube. And I don't know much about the technology of it, but it apparently is working fine. Now, all these things, it'll take a while to get results from, but there's at least 4 total successes going so far, and a couple that are questionable, and then the rest of them are dead. Other lunar activities recently. South Korea, they had launched a lunar orbiter back in August on a Falcon 9 in one of these low energy kind of orbits again. And they arrived December 16th. So they're there now. That worked as planned. And the other launch was just made on December 11th and had 2 big parts to it. This pretty much overlaps what was in the summary we were doing for the year. The Lunar Flashlight Project, which is also looking for ice in craters, specifically the ones near the South Pole. And, this is the one that has the propellant that's replacing hydrazine. And then the other one is the lunar lander in Japan. That was interesting. So, we have Houston companies that are hoping to be the first to land on the moon with a private lander. They're actually in a race with this company. Who knows how that's going to turn out, because this one is now launched, but it's not going to get there for another 5 months. So, if the other launches are not in such low energy orbits, maybe they'll get there. So who knows what's going to happen on that one. But that's the case where they got the lander, it's going on the way. It'll get there in 5 months. It will disgorge then the rover that's made by the United Arab Emirates and some other small payloads as well. Okay, the leak problems at the space station. This is a picture. If you look in the lower right side of that, you see some spray coming out. And this is a picture of the Soyuz spacecraft. And you're looking at somewhere in there on the lower right side, there's a place where there's a very small leak. And they've been trying to inspect with cameras mounted on robot arms and that sort of thing. And they haven't really pinpointed exactly what the problem is, but they do know they lost coolant. This is a major cooling loop that keeps the whole thing cool. And it's a problem not only for keeping the astronauts cool when it gets heated up, but even the equipment. They're worried if they can't do the cooling and they lose the computers, then you really have to fly back manually. Now, this is really a big deal for the space station because this is the life. And it's also just the normal return path. So they haven't decided yet if this is going to be a usable spacecraft or not. They don't really keep a lot of coolant up there, or maybe even a lot of welding equipment to fix things. So the thing may just have to be discarded. If they do that, then the Russians will send up a new Soyuz automated with no crew on it whatsoever, but they can do an automated docking without a crew. That's not a problem. And then, then they would take astronauts back that way. It would just mean this thing would simply get discarded. The other possibility is they take a chance and they go on this if they decide there's a way to make it work. The biggest question will be, will the navigational computers stand up to temperatures even now? It might actually get fried in the process. So we don't know that. The decisions have not been made. Okay, launches since the last meeting. We always do this. I got a picture here of the very last launch of the year. So that's a clue. That was on December 30th. This was actually an Israeli company launch. Interesting because it was going in an orbit against the direction of the Earth. And I think it's because their other satellites, typically they have military spy satellites, theirs are launched against the direction of rotation of the Earth simply because when they launch from Israel from their own rockets, they have to launch over the Mediterranean. So they've got to go west. Normally you go east, which is the direction you're going to get advantage like 1,000 miles an hour rotational speed of the Earth. So anyway, how many do people think that there have been since the last meeting, which is about a month? You're pretty close. You're always too high. But you keep working on it. You're gonna get it one of these days. I just know it. I'm impressed though. You keep coming down by orders of magnitude each time. So you're getting really, really close. On a logarithmic scale, you're almost there. Okay, so here's some of the launches. We already talked about a bunch of these here. Let's see, what were some of the ones I wanted to highlight? There was a Chinese launch, which is there's kind of a race. Like who's going to have the first methane-based engine to actually make it to orbit? And it looked like they were going to. The Chinese, they have I don't even know how to pronounce the name of this rocket, Zhuke or something, but it was methane and liquid oxygen. Its first stage, in fact, worked completely. It was the second stage that failed. So they were pretty close. They apparently have a booster that will work just fine with methane. Of course, they're competing with SpaceX's Starship, Blue Origin, maybe the Terran. I'm not sure of all the different ones, but that's sort of the newer designs are coming in often with methane as opposed to the kerosene of the Falcon 9 or hydrogen of SLS and a lot of the earlier Atlas kind of rockets. A lot of routine launches here by China, typically Earth observation satellites. A lot of them are kind of mysterious. You don't really know what's in them because they don't really tell you. And let's see, blah, blah, blah. O3B, it stands for the other 3 billion. This is yet another satellite communication project. In this case, it's a Middle Earth. It's actually Middle Earth orbit, a little higher orbit than most of the others have been for internet services. And that's actually by a Luxembourg company called SES. They launched one of theirs. Again, other 3 billion means the other 3 billion people who don't have internet access yet. That's an old name. It goes back to a company that actually went bankrupt a couple of years ago, but they bought it and they kept the name. Starlink, we already talked about that in the yearly summary. They've launched a total of 3,600 satellites altogether. Some of those have already been retired. Some of them are in the process of going from their initial orbit to final orbit. So it's always kind of a question of how you report those satellites, but they've launched that. The what?
The 3 Falcon 9 launches in a row.
Yeah, that was impressive. Yeah, they're really picking up the tempo. Now, typically, at least one of these would have been out of Vandenberg. I forget which one. Because any of the ones that go for polar orbits, they might as well launch out of Vandenberg. They don't care about being south. So
3 launches, 36 hours.
Yeah, that was impressive. And only one of them was, Starlink. They've actually definitely slowed down the tempo on these. I think they must be, they're planning for their new generations. They're not really in such a rush to get up the old ones anymore. There was a failure, Vega C. That's a new European rocket. They had one success previously. This one failed. They actually lost a couple of satellites because of that. Now, the other Starlink launch here, this one was kind of a puzzle for people because they went up, the way Starlink was licensed is they have a whole set of a very large number of satellites in orbital shells, meaning a particular orientation and a particular distance. And they have some new ones coming in for their Generation 2 satellites, which are supposed to be quite a bit bigger and with more capabilities. And they set up a launch of 54 satellites on a Falcon 9, which normally means the version 1.5 that they've had in the past. Nobody quite knows why they did it because they sent it to the orbit of the new generation. So what they launched may not quite match up with what the licensing was. It's kind of confusing, and they're not really talking about it too much. Some classified satellites, the Israeli one I talked about. And then the only other thing is the first launch and the only launch so far this year is one of these transporter missions. And that's just the name that SpaceX gives to their ones where they consolidate and they take up a whole large number of very small satellites, 114 in this case. 36 of them were from one of the Earth observation satellites of Planet Labs. 12 of them were Space Bees, which are the ham sandwich sized satellites for Internet of Things communications. A lot of them are really, really small, but it's still 114. This is actually the biggest threat to the small rocket makers like Big Ductron rocket by Rocket Lab, is that they're competing against these huge quantities that can go up in one big ride when you package them together. This is the 6th of that series, and they're going to continue doing this.
So it's just a whole bunch of
they just collect them. Yeah. And in fact, in that 114, they may actually include a couple of space tugs from Beagle Ride or some of these others that, in fact, they're going to be launched. And then later on, they will just launch some additional smaller satellites. So the whole business has gotten really complicated. If you want small satellites, there's a lot of ways to get them up there. You may have trouble getting them where you want to put them. That's the problem, because these launches are typically to a sun-synchronous orbit, which is a polar orbit, meaning going over the poles or close to it. And those are set up so that you pretty much pass over any given spot on Earth at the same time. That's the sun-synchronous part. And that's very popular because if you're doing Earth observation satellites, you'd like to know that every day, you can find out at 2 o'clock. That kind of thing. So it's kind of a big deal. That's why they're doing so many of these. That's pretty much it. You already heard the other news. So, and then, yeah. Any questions about this?
The other thing is the basic that SpaceX launched three rockets rockets in 36 hours.
Yeah, yeah.
I mean, yeah, it used to be cool to see a rocket launching every 90 days.
Okay, thank you.
Thank you.